This video is Simplifying Rational Expressions Part 1. A rational expression is just a fraction that has a polynomial on the top and a polynomial on the bottom. In this case, we have monomial over monomial, but we can have binomials and trinomials. When it is the monomial over monomial situation, this is easy to deal with because this is just using your exponent laws. With the exponent law, we know to look at the 8 over 16, the coefficient situation, and it just reduces to a half. For the x's, you have x to the 10th over x to the 7th. That's just a matter of keep the base and subtract the exponents. The x to the 3rd goes on the top because there were more x's to begin with. Look at the y's. There are more y's in the bottom, so that when we subtract 5 from 8, we're going to have a y to the 3rd in the bottom. For the z's, z is the same as z to the 1st, so that means there are more z's in the bottom. Our answer for the z will be in the bottom, and when we subtract 1 from 2, we get z to the 1st. So that's monomial over monomial. And the reason you're allowed to cancel individually like this with the monomials is because this is written as a product. 8x to the 10th, y to the 5th, z means 8 times x to the 10th times y to the 5th times z. Same idea for the denominator. This is all multiplication. So when things are written as products, you are allowed to cancel piece by piece. But when you have binomials and trinomials, those are not products. Those are sums or differences, and we have to handle those differently. So simplifying monomial over monomial, just use your exponent laws. When you have binomials and trinomials, you must write them as products first, which means you must factor those. Pause the video here if you need to and write this information down, but the key idea here is when you have binomials or trinomials, you must factor them out before you do any canceling. Now, x squared minus 16 is the difference of two squares. The bottom of this is just a matter of taking out a GCF of 4. So here it is in the factored form. Notice you have a binomial x plus 4 with a binomial x plus 4. We can cancel those. When you cancel those out, you are left with x minus 4 over 4. You can't cancel the 4 with the 4 because that's a monomial, that's a binomial. This top right now is not written as a product. So this is as far as we can go with our simplifying. Bottom line is this. You can cancel a monomial with any monomial. You can only cancel identical binomials. And you cannot ever cancel a monomial with part of a binomial, nor can you cancel part of a binomial with part of another binomial. To understand this a little better, I'm going to show you something with numbers. Take the fraction 17 over 7, which you know does not reduce. Well, I'm going to play a little trick here. Let's write 17 as 10 plus 7. Now, would you think about canceling those 7s? I mean, we just said we're not allowed to, but let's pretend we could. Cancel those 7s. Now we have that this is the same as 10. Does that mean the fraction 17 over 7 just equals 10? There's no way that those are equal. So that means that is a big no-no. You cannot cancel a monomial with part of a binomial. And if we're not allowed to do it with numbers, we're not allowed to do it with letters. This is very tempting to try to cancel those x's, but you can't do it. What you are allowed to do, and this is why students get confused, is if you have the monomial 2 times x over x, then yes, you are allowed to cancel those x's, but that's because that's a product, that's a monomial, and that's what you're allowed to do. One more number example. Take 15 over 25. Now 15 over 25 does reduce by 5 and gives us the fraction 3/5. Well, let's do the same little trick with rewriting these as a sum. 15 can be thought of as 10 plus 5. 25 is 20 plus 5. If I were allowed to do this kind of individual canceling, I could cancel the 5s, and 10 over 20, the zeros cancel out, and I would just get the fraction 1/2. Well, we just said a minute ago, 15 over 25 reduces to 3/5, which does not equal 1/2. So here's another big no-no. If you can't do it with numbers, you can't do it with letters. Very tempting to try to cancel out those x's, but you can't do it. That's as far as this expression will go. So let's go back and look at a couple more examples. To simplify rational expressions that contain binomials or trinomials, we must factor them. Now this video assumes you remember your factoring techniques. If you don't, go back and look at all the factoring videos that I've already posted. So x squared plus 6x plus 8 factors as x plus 4 over x plus 2. X squared plus 7x plus 12 factors this way. Notice you have identical binomials, x plus 4 x plus 4, and what you're left with is x plus 2 over x plus 3. This top factoring, you might want to think about using tic-tac-toe. The bottom is taking out the GCF. You could pause right here and see if you could factor this on your own. This is how it factors. We have written it as a product. This is this times the 2x plus 5. This is 4x times 2x plus 5. We have written it as a product. We are now allowed to cancel out the 2x plus 5s. And we have 3x minus 1 over 4x. Now I dropped the parentheses. I could have kept the parentheses around that. They're just not necessary. This is another one that is just a matter of taking out a GCF out of both of them. Pause and factor it on your own, and then look back. The top I can take out a 4x squared, leaving a 2x minus 3. The bottom I can only take out an 8x cubed, leaving an x plus 2. The binomials have nothing in common. I can't cancel those out. But the monomials can be canceled with any other monomial anytime. So just focus on that. The 4 over 8 reduces to a half. X squared over x cubed, that's just using your exponent laws, and you end up with 1 over 2x. Of course, the 2x minus 3 is still part of the top, and the x plus 2 is still part of the bottom, and that's your answer. Now, I can clean this up a teeny bit by getting rid of that 1, and I just end up with 2x minus 3 over this.